Now that I'm back from Moab, I took my blue solid axle swap Tahoe to Moab. It's time to get back on the solid axle swapping my white Tahoe. And per everyone's requests, my last videos I didn't go into all of the tiny details of doing the swap. So this time I'm doing a lot more in-depth videos about the things I'm doing. So this video is going to be about doing the radius arms, or at least getting them started. They won't be built in this video, but at least getting started and some of the things that I do to prepare for building a radius arms, what I purchase, and how I start getting them ready. So now you see I've got the front axle housing, the springs, the shock mounts, and I've gone and picked myself up some of the other parts I'm going to need, that like the universal link mounts that we use for the cross member, some universal bushing assemblies. Here's the inner sleeve, the two bushing halves, and the outer sleeve. Not that it really matters, but I like to have this drilled and tapped first, so then you can kind of orient the fitting where you want before you tack weld everything, because then one less thing you've got to get jigged up as one big radius arm instead of just a little bushing. You can drill and tap in a vise a lot easier. This is a tapered pipe thread fitting. This one is a straight thread fitting. You actually want to use the tapered pipe thread fitting because since it's a tapered thread, you can index it and still have it be tight and sealed and have it point where you want when you're done installing and threading it. Oh, it's too big. Yeah, that'll work. Hyper step drill bits. Don't require a pilot hole. It's pretty cool. So these get dull really fast, so I have to replace them a lot, but stepless drill bits. They work great. So pipe thread taps are tapered. And this is not the exact same taper, but it's close enough that it makes it for a lot better of a tapping when you go to actually start threading the hole. Because if it's a square drilled hole, you're just trying to catch and ream out as you drill. Now there's a nice tapered hole. Look how nice that tap just rests in the hole to get started. Then we're trying to fight that tap straight while you're starting. So what I have decided to do is I've decided to go with square tubing. So I'm still going to do 2-inch and 1/4-inch thick wall, but I'm going to do square tubing instead of round tubing on this build. And that's because on this build, I want to do, some things that are a little bit different. We've already proven on, the first one, the 2-inch by 1/4 wall DOM tubing works fine. I want to show you that square tube by 1/4 wall actually works just as well. In fact, you're seeing a lot of builds these days go with the square tube instead of the round. So I thought, you know what? Let's do that different. Just show that we can. And another thing that I'm going to do differently is these weld-on bushings. I've decided to get 4 of them. I'm not going to put Johnny joints on the radius arms. I'm going to do a weld-on bushing sleeve and polyurethane bushing on all four ends of the lower control arm portion of the radius arms. That's mostly so that I can see the difference in the flex. I'm really curious, how much more or less flex we get with Johnny joints versus polyurethane bushings in this particular configuration. So I'm going to do that. You know what? If I just absolutely hate it, I can add Johnny joints really easily. So at this point, I'm going to do just weld-on polyurethane bushing sets for the radius arms. So yeah, I mean, that's one of the differences in the build. So square tube and no Johnny joints. I'm going to do that, just something different, because we've already seen what it looks like, with Johnny joints and round tube. I'm here to see how much I can get metal for. I'm at the most expensive place in town to get metal as well. I'm not even going to like my cheap supplier that I get a good deal on. That looks like quarter wall, 2x2. Six and a half feet. It's like the absolute perfect length. So these are remnants, so it's sold by the pound. So like, what did it say? $1.39 a pound. Traditionally, Metal Mart's pretty expensive. This piece weighed out at 36 pounds, but he only charged me for 20, so that's pretty cool. I didn't even ask him to do that. Oh. $29.82. So here's a good example of what I used on the last build, which is 2-inch by quarter wall round tube. And here is 2-inch by quarter wall square tube. So they both still have, an inside diameter of 1.5 inches. So even if I were to do Johnny joints with the weld-in threaded inserts, it still bottoms out and centers inside there and can be welded pretty easily. I don't have any of those because I'm not going that route with this build. And I wanted to try the weld-on bushings because I'm actually trying to streamline and simplify the process. As you've heard me talk about in other builds, with the radius arms, once you've got them, set to the length you need, you actually don't really need to adjust them much. So you don't need that adjustable shank for the Johnny joint. And we already know that radius arms do like to have polyurethane joints, just as part of the inherent function of radius arms. The way that they work, sometimes they fight, and so having that little tiny bit of off-axis give that polyurethane gives allows it to flex a lot more. That's why if you were to use just all Heim joints on radius arms, they actually don't flex as much as if you use a joint that has polyurethane, because the Heims are just such a tight socket, and they only will flex and rotate on their own tight axis. So I want to take and build these radius arms different, which is I'm going to build them all one piece with no adjustability in the lower control arm section. It'll still have an adjustable upper locating arm, but it will not have an adjustable lower control arm portion. As you can see in the original build here, that it's 2-inch by quarter wall DOM tubing. And I actually, on the last build, did Johnny joints on both ends. Mostly just because I was just building it kind of for overkill, kind of just, going as I went. And so the lower control arm portion was 2-inch by quarter wall DOM with Johnny joints at the frame and axle end. And then the upper radius arm portion, had obviously adjustability. And you need to have the adjustability in the upper locating arm portion. And that is so that you can adjust caster and pinion angle to work for the double cardan drive shaft. So I will still have joints because I think it'll definitely need that. I'm just talking for the lower control arm portion of the radius arm, because what makes it a radius arm is the lower control arm portion tied together with the upper locating arm. And so the plan is to get it all mocked up, get the joints all in, get it all tacked together and make sure it all works and then full weld it, just to show that you can actually probably build these arms even simpler with just weld on bushing sleeves right onto the end of 2-inch by quarter wall square tubing. And I mean, that's going to be great. So that's what the goal is to show you what else can be done. We already know what can be done when it comes to DOM tube and johnny joints. That's been proven. Let's show something else now. So as I showed you, I drilled these sleeves to put grease fittings on them. And as part of the kits that are only like 20 bucks each is this outer sleeve, which you can buy these, I mean, so many places. This is a standard 2 5/8 joint. And so these kits can be purchased numerous places. And it comes with an outer sleeve that you can drill and put a grease fitting in. I recommend you do that. And an inner sleeve, and that's for the bolt. And then 2 polyurethane bushing halves. So the polyurethane bushing halves each go in, boom, boom, each side pressed in. A little bit of lube goes a long way. You won't get the polyurethane bushing halves into this sleeve if you have this already pushed into one of them, because when you push this in, it expands these bushings just ever so much and makes it just too much larger to get in. So you have to do it that way. You have to do bearing sleeve, push in your bushing halves, and then push in your inner bushing. So see, I can push it in by hand for the most part. A lot of times you might have to use it. So that's what it looks like when it's fully assembled. Then you'll press the inner sleeve in. So what I'm going to need to do is have these actually fully assembled with the inner sleeve already installed, and then in the bolted positions with the axle mocked into place at the front and the cross member already built. And then I will cope the square tube for the radius of this tubing, and I will get it up into place and tack weld it. And I can't fully weld this with these bushing halves in it. So once I get it all tacked together, I can take it back apart, pop out the polyurethane, and fully weld it, because the heat from the welding is going to melt the polyurethane. So you can tack weld it, that's fine. The heat from tack welding isn't going to be enough to melt these polyurethane bushings. So you can tack weld it, get it, good strong tack welds, but then you can take it all apart and full weld it. What I'm also going to do is I'm going to order some of these. And those are actually intended for Jeeps, but since this axle is made by Mopar, and it is the same joint that a Jeep takes, I'm thinking that the Jeep ones will work, and the ones on my previous Tahoe have taken a pretty big beating. So I figure I'm going to order some and try them out and see how they work. I think that it's not going to hurt. And if they don't work, then you guys won't, you'll know, and won't have to waste your money on, buying some for yourselves. So on the new axle, I'm gonna weld those on as well, just to protect the lower control arm mounts from just taking a beating, because they do kind of hang below the axle tube, and they just hang out there for rocks and everything, just to beat the crap out of. So a little bit of armor right there, I think, is a good idea, and it'll go a long way.